Today I'm going to be teaching you about arc length in a flight integral. So as we can see here, we have two functions here. So, oops. So we have f of x, which is on the left side. So if we are on f of x, the formula that we're going to use is the integral of, the antiderivative of the square root of 1 plus the quantity of dy dx raised to the second power dx to the interval of a to the b. Also, f of x is just equals to y, and g of y is equals to x. So what's really is going on here is we're just going to approximate its length of this function. So we're just going to approximate this length of here. So this just like these things. So just all the distances from those things. And also on this one. That's just it. So this is the use of this formula on how we will evaluate or approximate the length of a specific function. So let's call this point A. This is from A to some value y. So this point, let's call this B, from B comma y at another point from y. And now let's call this something. Let's call this x. X, yeah, x. Some value at x and then y to c. And then point B, just in some value x. I might put x up to, but I'm lazy. And then to interval t. So on this equation, that's the equation that we're going to use if we have a function of g of y. So we're just going to do some practice problems. Now let's move on to our first problem. 8x squared equals to 27y raised to the third power. And on the bottom, it is this function. So we're just going to find the length from point A to point B. So the first thing that we're going to do is just solve for the value of y. We can also solve for the value of x here. So we can get the function in g of x. But for here, we're just going to solve for y, so we can get f of x as our function. If we solve for x, we will get g of y, right? So this is it. So we are just isolated y here as our f of x. Then we got this thing. So we're going to use some law of algebra here by distributing or the cube root function. The cube root. So we get this 2x squared over 3. Then 3. Cube root of 27 is 3. And cube root of 8 is 2. So now what we're going to do is just take the derivative of both sides with respect to x. So we can have dy dx. So let's go ahead and do that. Okay, so let's take the derivative of this thing with respect to x. So we will get by implicit differentiation. Wow, okay, I'm gonna speak that again. dy dx equals to 2/3 and the derivative of x raised to the 2/3. So dy dx equals to 2 over 3, and then we can just use the power rule. So we get this. So 2/3 minus 3 over 3, right? Because it's just going to be 1. So we're just fast as cool. So 2 times 2 is 4, and then we got 9. And now we got 3 times 2 at the numerator, so we've got, no, not 2, but minus it. Okay, got x equals to negative 1/3. Next. So we got 4 over 9 now. I'm just rewriting things. We can just put this in the bottom, right? And then let's square it. Because in the formula, we need this in squared, right? So, let's go with this 16. This is going to be 9 times 9 is 81. And then this is just going to be x raised to the 2 over 3 again. So we just come back on that form. So this is our square root. I mean the dy dx raised to the second power. So we can just put this in our formula. So what is our formula again? So our formula is just the antiderivative of the square root of 1 plus the quantity of dy dx raised to the second power dx on the interval of a to b. So we can just put it there. So that is the purpose of what we've been doing this past minutes. So we have 1 over 8, 1 plus. So our dy dx is going to be 1681x raised to the 2 over 3 dx. Okay, so now what we're going to do is solve this integral. Definite integral. So we can just factor out some kind of stuffs here. We can rewrite this thing as, whoops, so I did up with the 18. So we get, okay, negative 2/3. We can just rewrite it, right? And then the next step, what we're going to do is just factor this thing out. So let's factor x raised to the negative 2/3. There you have it. And then what we will get here is just x raised to the 2/3, and it's just positive. So if we're going to distribute that thing into that thing, so we'll just get 1. So that's basically it if we factor this out. So now let's use u substitution. So let's use u as in x raised to the 2/3 plus 16 over 81. So let's take the derivative of both sides. So this is just going to be 2/3 x raised to the 2/3 minus 3 over 3. And then 16 over 81 is just going to be 0. So we'll just put the x. Next up, I'm not gonna delete that thing. Okay. So I just forgot this, that we can just... Okay now. So just going to be x raised to the negative 1/3 dx. Next, so this thing, we can just split the radical sign. So we have integral of 1 over to 8. We can just do is split this thing. So we can just write this like this, right? Then we can just raise it to the 1/2 power. So we have x raised to the 2 over 3 plus 16 over 81. So as we can see here, the thing that we're going to cancel is the 2. So we just cancel the 2. And what we left here is just x raised to the negative 1 over 3. So now we got this thing. And then you just rewrite this thing because we're still not done. So 16 over 81, 10 dx. Okay, let's just delete this. So now we're going to change 1 and 8 because we did use u substitution, meaning we're not integrating with respect to dx but with respect to du. So we can just put this on the bottom, right? Just dividing both sides. So we got that thing. Now let's plug in some things here. Let me delete this. So now let's plug in x equals to 1. And then we're just going to solve for u. So as u is equals to, inside the radical sign, just x raised to the 2/3 plus 16 over 81. And our x is just 1. Let's use x equals to 1 first. Just going to replace those things, those intervals. So we got 1 here, because the square root of I mean 1 raised to the second power is 1. Cube root of 1 is just 1. So this is going to be the one become 81 over 81 plus 16 over 81. Then this is just going to become 97 over 81. So this is the new value of 1, which is going to be 97 over 81. Let me just delete these things. So x is going to be 8. So what is the new value of u here? So just going to be the cube root of 8, and it is raised to the second power inside the radical side. 16 over 81 here. So the square 8 raised to the second power is 64 plus 16 over 81. I'm gonna write it there because it's 2. Okay, so we got this. I did skip some scenes, but this is the final answer. So doing some work, this is our final. What I did there is just use the definition of definite integral in the fundamental theorem by calculus. We just replace the x value with the new ones and then do some integration. So we just arrive in this answer, which is 330, the cube root of 337 over 81 raised to the second power minus cube root of 97 over 81 raised to the second power. So approximating our value, as we just use our calculator because this is too much, this is too big, so we got 1.4 as our 1.4868. That's our now let's go to our second problem. So the quantity of y plus y raised to the second power is equals to the quantity of x minus 4 raised to the third power, and from point A to point B. So now, instead of solving for y, we're going to solve for x. So let's raise both sides by raised to the 1/3. Okay, so now what we will have here is quantity of y plus y. Y plus 1 raised to the 2/3 is equal to x minus 4. So we're just going to put the -4 to the left side. So we can just write it like this. So plus 4 is equal to x. Now, we can differentiate this, take the derivative of both sides with respect to y. So we got d. So we will get this thing. We can just write it as 2 over 3 once again. And then we're going to take the derivative of it with respect to y. So we're going to take the derivative of 4. And this is going to be dx dy. So now let me delete the things on the top. Okay, now let's do some derivative things. So we got 2/3 here. Then we got y plus 1 here. Then we're still going to use the derivative here. There you go. We're going to take the derivative of 1. And we also have 2/3 here. Minus 3 over 3. We just use chain rule, right? Okay, you get this. Dx dy. So now, let me delete this thing. Okay, so we got 2/3 and then y plus 1 negative 1 over 3. And then this is just going to become 1, no? So we got dx dy here also. So now let's just raise this both sides from the second power. So we can just plug it into our formula later with ease. Okay, let's do that. So let's raise this to the second power. So in order to master this topic, you just need to solve some problems. Keep solving problems. So we got 4 over 9. We're just going to distribute the exponent of the 2. So we will got negative 2 over 3 once again. And that's it. That is the dx dy raised to the second power. So it's just 4 over 9 times y plus 1 raised to the negative 2 thirds. Plug it into our formula. So what was our formula? So it's just the antiderivative of the square root of 1 plus dx dy raised to the second power dx to the interval of c to d. So that is our formula, our equation. So let's just plug it in. So we're going to take it from 0 to 7. And then 1 plus our dx dy is going to be 4 over 9. And then y plus 1 raised to the negative 2 thirds. Then we're just going to put dy here. Okay. Damn, look at my radical sign. It bends. That's funny. Okay. Let's keep going. So what we can do here is just factor out the quantity of y plus 1 raised to the negative 2 thirds. Right? We can just do that. So let's just do it. So what will happen here is just going to become y plus 1 raised to the 2 thirds. And then 4 over 9 will become alone. Just going to be alone. So if we're going to distribute it once again, we will arrive on that form once again. No, let me delete the top one. So now, what we can do here is just use substitution. So let's say, no. What we're going to do is just separate this. Wow, I'm too excited for use substitution. So 0 to 7. Then y plus 1 raised to the negative 2 thirds. And times 1 half. I just rewrite the radical sign with 1 half because they are just the same. Plus over 4 over 9 here. And then we got dy. So L, our arc length, is going to be 0 to 7. Then we can just cancel the 2's. So just we will have left negative 1 third. And still multiplied by y plus raised to the 2 thirds plus 4 over 9 dy. So we can just get rid of the bottom here. So now we can just use substitution, our favorite. So let u equal to the radical sign inside the radical sign. So it's just going to be quantity y plus 1 raised to the 2 thirds plus 4 over 9. Now let's take the derivative of this thing. So just using chain rule, we can just get this. So 2 thirds y plus 1, 2 thirds minus 3 over 3. Right? And then we're just going to take the derivative of the inside function, which is just going to become 1. And then the derivative of constant is just 0. So now we got this. So we got this thing. du is equal to 2 thirds quantity y plus 1 raised to the negative 1 thirds dy. Oh yeah. I was gonna put dx. I was so used to dx. Right? Just dy. Okay, this is so long. Our work is so long. So now we can just divide both sides and then put this in our denominator. And then we can just solve for the new values of u. The new values of x. So if x equals to 0, what is the value of u? Okay, let's do that. So let's say x equals to 0. So u is going to become square root of u is... Okay, I thought it is x, but it is y. That's why I deleted it. So u is going to become 0 plus 1 raised to the 2 thirds plus 4 over 9. Then we just got this. It's going to become 9 over 9 plus 4 over 9, right? Then 9 plus 4 is just going to become 13. So this is just going to 9. And that is the new value of 0. It's just 13 over 9. So now let's say if y is equals to 7. So what is the new value of u? So just going to become this thing. So nope, I think I'm not going to do that. That will take too long. So we can just basically do it in is. Just say 8. Then cube root and then square root 4 over 9 here. And then we got this thing. So 8 squared is 64 and cube root of 64 is just going to become 4. So our u is going to become 4 plus 4 over 9. Okay, let me do this thing. So we can just add this. So u is going to become 9 times 4 is 36 and then over 4. I mean 9. 4 over 9 and then we got this. So u is going to become 40 over 9. So that is the new value of 7. It's 40 over 9. So now we calculated everything, the new value of u's, and we can just plug it here. So we got 13 over 9, right? So we got 13 over 9 and then 40 over 9. And then we still have the y plus 1 raised to the negative 1 over 3 earlier. And our integral, I mean the radical sign, is going to be u. So we got this thing. We just write it in this form now. So it's just going to become easy. Easy to evaluate. Okay, let's just scan on this. Delete these things. So now we're going to integrate this. We can just cancel the y plus 1 thing here and then use fundamental theorem of calculus to solve this problem. So we got 3 over 2 and then 1 half plus 1, or we can just put 2 over 2 so it make things easier. So 1 half plus 2 over 2, and then from 13 over 9 to 40 over 9. Okay, we got this, and now we can just basically simplify this thing. So it's just going to become 3 over 2. So 3 plus 1 on the bottom, that is just going to become 2 over 3. Let's do that. We can just cancel this. And then still evaluated from 13 over 9 to 40 over 9. Now let's delete this. Okay now. So let's do it. So just going to replace u with 40 over 9. So this is what I did earlier. I just didn't record it because my laptop just freeze. I don't know, because I think I was charging while using it. Okay, so we got this thing. Now you know how to do it. So the arc length using our calculator is just an approximate value. So it's just going to be 2.7 minus. Okay, let me type this. Okay, so we got 1.2778. Now taking the difference of these two, so our arc length is going to be approximately 1.422187. And that is it for this video. I hope you learned something.